Imagine relying on someone else's eyes to see where you're going. That's what India was doing for decades, relying on foreign navigation systems like GPS of USA, GLONASS of Russia, and Galileo of Europe. But why? Because we did not have our own satellite navigation system. Today, we are diving into the fascinating journey of India's quest for self-reliance in space technology, the importance of atomic clocks, and how a tiny malfunction almost derailed our dreams. Welcome to Snap, where we break down science to its simplest blocks. Before we get into the science, let's rewind to a moment in history which shook India's defense establishment, the Kargil War of 1999. During the war, India faced a harsh reality. It realized that its dependency on foreign technology could be weaponized against it. The United States of America, which owned the GPS, denied access to precise GPS data during the conflict. This severely hampered India's ability to precisely locate enemy positions and plan strategic operations. Without accurate GPS data, Indian Air Force had to rely on aerial reconnaissance using cameras mounted on fighter jets. Yes, you heard that right. Our pilots had to fly over enemy territory, take photographs, and bring them back for analysis. This was not only risky, but also time-consuming, putting India at a severe disadvantage. This was also a wake-up call for India to develop its own navigation system, which cannot be turned off by other nations during the time of crisis. Fast forward to 2006, India decided to take the matter in its own hands. The Indian Space Research Organization, or ISRO, launched Indian Regional Navigation Satellite System, IRNSS, which was later renamed to NAVIC, Navigation with Indian Constellation. The goal was to provide accurate positioning and timing services over India and surrounding regions, independent of foreign systems. Now, here's where things get really interesting. At the heart of every navigation satellite is a clock. Not just any clock, but atomic clocks. But why are clocks so important? Because navigation satellites work on a simple principle: triangulation. You see, signals are sent from satellites to your devices, and the time it takes for those signals to reach your device is used to calculate your position. So the more accurate the clock, the more precise your position will be. Think of it like this. If the clock in satellite is off by just 1 microsecond, that's 1/1,000,000th of a second, your position on Earth could be off by 300 meters. That's the difference between an aircraft landing in a runway or ending up in a field. Now, let's look at what makes atomic clocks so accurate. Because they don't rely on pendulums or gears like regular clocks. Instead, they use the vibration of atoms to keep time. And here's the cool part. These vibrations are so consistent that atomic clocks are accurate to within 1 second in millions of years. Inside an atomic clock, there's a bunch of cesium or rubidium atoms. Let's consider cesium. When you expose these atoms to microwave radiation, they start vibrating. These vibrations have a super specific frequency, that is 9,192,631,770 times per second. Yes, these many vibrations every single second. Now the clock's job is to tune the microwave radiation to this exact frequency. When it does that, cesium atoms resonate, kind of like how a guitar resonates when you pluck at the right pitch. The atomic clocks use this resonance to measure time. But here's where India hit a major roadblock. In 2017, 3 of 9 atomic clocks in NAVIC satellites failed. These weren't just any clocks. These were imported clocks from Europe at a staggering cost of $200,000 each. That's approximately 1.75 crores in today's value for each clock. This failure was a huge setback, questioning reliability on foreign technology and the future of NAVIC. But why did these clocks fail? While Isro has not released an official report, experts speculate that it could be the radiation in space or manufacturing defects that might have caused this. Whatever be the reason, it's yet another wake-up call for India to start manufacturing its own atomic clocks. Thankfully, Isro, along with several Indian institutions, is working on building its own indigenous atomic clocks. NAVIC is designed with a constellation of 7 satellites and a network of ground stations operating 24/7. 3 satellites of the constellation are placed in geostationary orbit. That is, satellites in a fixed position above the Earth's equator, matching the planet's rotation, appearing stationary from the ground. 4 satellites are placed in inclined geosynchronous orbits. That is, satellites with an orbit that matches the Earth's rotation period, but its path may be inclined or elliptical and not always fixed over the equator. The NAVIC satellites offers 2 different types of services. The standard positioning service, which is open for general and commercial use, or the restricted service, which is open for military and defense purposes over Indian landmass and neighboring regions. The positioning accuracy is estimated to be up to 5 meters over India and 10 meters over neighboring regions. To conclude, from the lessons of Kargil war to the challenges in atomic clocks, India's journey in satellite navigation is a testament to science and determination. So the next time you use navigational services, remember there's a whole world of precision engineering and atomic clocks making it possible. Thanks for watching. Don't forget to like, share and subscribe. For more awe-inspiring stories of science and tech, follow Snap.